so today's lesson objective, students will graph and write absolute value functions. So the first thing we'll talk about is the parent graph, which is the most basic absolute value graph you would have. F of x is equal to the absolute value of x. So I could make myself a quick little table over here on the side. So when I plug in a -2, y is 2. If I plug in a -1, y is 1. 0, 1, 2. So if I plot those points, what happens is that the graph makes a V. And so every absolute value function should make a V. And so some pieces of it, this is the vertex. So the parent graph, we have our vertex at 0, 0. Each side is linear, but the graph as a whole is not linear. This side here on the right side is just the line y equals x, and the other side is the line y equals negative x. And so the basic graph, like the slope of the right side is just 1, right? And the slope of the other side is -1. So when we're graphing this basic one, the slope is just going to be 1 and -1. As long as there's nothing in front of that. Alright, so sometimes our graphs might be translated, and the form for a translated graph is y equals the absolute value of x minus h plus k. A translation is a kind of transformation. Transformation is when you transform something, you change it, right? So a transformation can change the size. It could change the shape. It might change the position or the orientation of a graph. A transformation can change the size, shape, position, or orientation of the graph. What a translation does, it's a transformation that affects the position. What it's going to do is it's either going to shift it horizontally or vertically or both. So shift horizontally or vertically or both. So for instance, I can take my graph here, this is my parent graph, at 0, 0, and I can move it. If I decide to shift it to the right 2 and up 3, now it's in a new position. Okay, so now I've got it where my vertex is at 2, 3, right? So I shifted it horizontally 2 units to the right. So my h, that gives me my horizontal shift. And the k will give me my vertical shift. So now I can write the equation of that graph, the new graph that I moved, using the y equals x minus h plus k. So the equation of that would be y equals the absolute value of x minus, what's my h? 2, right? I moved it to the right 2. And then plus k, how much did I move it up? 3. Okay? So you see how the vertex shows up in the equation? The vertex is like that, right? Okay. I could also shift the other way. I could decide to shift it over here. So in that case, I went backwards 5, so I went negative 5, right? And then I went down 4, so negative 4. So for that one, my h is negative 5, my k is negative 4. So if I want to write that equation, if I do x minus a negative 5, what happens? It becomes plus 5. And then minus 4. Okay? So any questions there? So when you're graphing them still, there's nothing in front of that absolute value. It's still just a slope of 1. We just moved where the vertex is. It's the same exact shape otherwise, okay? So now we're going to graph y equals the absolute value of x plus 4 minus 2, and I'm going to compare it with the graph of y equals the absolute value of x. So I've already got my parent graph up there. That's what the black one is. So if I look at this equation, I can see what is my h going to have to equal. Well, it's a plus 4, but what's it supposed to be? It's supposed to be x minus h, isn't it? So that means the 4 must have been negative. So I'm going to be shifting it horizontally, negative 4. So is that going left or right? Which way is our leg? Yeah, we're going to go left. So that's the negative x direction. All right, and so my k is equal to negative 2. Because remember, it was supposed to be a plus k. So yeah, negative 2. So negative 2, my negative y direction means I'm going down. Yeah. All right, so I start at 0, 0, where the parent graph was. I go to the left 4 and down 2, so here is my new vertex. And then just up 1 over 1, up 1 over 1. And then the opposite over here. And that's my new graph. And so if I compare it to the original graph, it is shifted left 4 units. And down 2 units. 2 units. Okay? And my vertex here is at negative 4. Right? Any questions? Yeah, when it says to compare it, you should write down, yeah, how it compares to the parent. Okay? So on your whiteboards, which there should be one on your desk, I'm going to have you guys graph this one and then tell me how it compares. If you want to, why don't you guys first show me what h and k are if you want to just make sure you've got that right. Show me your h and k values. Okay, so do we agree that h is a positive 2 and k is a positive 5? Okay. All right, so it looks like you guys, most of you are getting it. We go to the right 2 and up 5. Here's our vertex at 2, 5. And then we have a slope of 1, so up 1 over 1, up 1 over 1, the other direction. So you graph like that, and relative to the other one, it was shifted right 2 units and up 5 units. All right, so we're good on those? Okay. All right, so sometimes we can stretch it or shrink it or reflect it. copy down that chart. I have the parent graphs already on there. I'm going to compare them to the new graph, so that's why they all look the same right now. They'll look different when I'm done with them, though. All right, so if A is greater than 1, the absolute value of A is greater than 1, so it could be negative, but if it's more than 1, then what happens to the graph is that it stretches it. It stretches it vertically. And the net effect of that is, so where it was 1 before, it might be 2 or 3 or some larger number. So the effect is that my graph ends up being narrower. And if the absolute value of A is less than 1, so say it's 1/2 or 1/3 or a fraction that's less than 1, then what happens is that it shrinks it vertically. And the net effect of that is that it ends up being wider. And if A is equal to -1, it reflects it across the x-axis. So essentially what happens is it ends up being upside down. And if A is like -3 or -5, it's going to be upside down, plus it's going to be narrower. If it was like -1/2, -2/3, it would be upside down and wider. So you can also have both things happen. So the first one I'm going to graph is y equals 1/2 times the absolute value of f. So this one's not translated or moved anywhere. It's just being shrunk, right? So when I go to graph it, I could make a table if I want to. And I'll put in -2, 0, and 2. If I do that, I end up with 1, 0, 1. And so the graph ends up being like that. If I go ahead and put the parent graph on here, how does it compare to that parent graph? It's wider and it's shrunk, right? So it shrunk by a factor of 1/2. So do you know, one thing you might notice is that what happens is that's my slope for the positive side, right? I go up 1 over 2, up 1 over 2. You guys see that? See the slope? Okay. So that will help you graph it if you realize that's your slope. You actually don't have to make the table. So looking at B, I've got a -3. So what's my slope going to be on the right side? -3. So I'm going to be starting at 0, 0. I'm going to go down 3 and to the right 1. So that's a way you can avoid making a table if you want. You can actually just graph it straight to the information and then just do the mirror image on the other side. So that one, the graph is going to look like that. So relative to the parent graph, what can we say about that one? A little louder, somebody said something. What mark I think you're doing? It's a reflection, okay, so it's upside down, right? isn't it? By a factor of 3. So in other words, it's narrower, right? Okay. Any questions there? Alrighty, so you guys get to do this one, graph it, and then tell me how it compares. Alright, so I think we all agree it came out to be wider. It was shrunk by a factor of 1/4. And it looks like most of you were getting that. Not any problem. Okay, so sometimes we can have multiple transformations. We can shrink it or stretch it and shift it. We're going to put it all together now. So that form is y equals a times the absolute value of x minus h plus k. So if I look at y equals negative 2 times the absolute value of x minus 1 plus 3. I'm going to graph that, and I'm going to compare it to my graph of y equals the absolute value of x. So before I graph it, I'm going to look at all the parts of it. My a is equal to negative 2. So am I stretching it or shrinking it? I'm stretching it, right? And what else am I doing to it? It's a negative 2, so what's going to happen? It's going to be flipped over, right? It's going to be a reflection. Okay, so I'm going to stretch it and I'm going to reflect it. And what is h equal to? H equals a positive 1, which means I'm going left or right? Left to the right. And then k is equal to positive 3. And so positive, I'm going up. All right, so now I'm going to come over to my graph. If I start at my 0, 0, I'm going to go to the right one, and that's 3. There's my vertex. And my slope now is going to be a negative 2, so I'm going to go down 2 to the right one, and do the same thing on the other side. Mirror image. Do a couple more. And there's my graph. So when I compare them, it is stretched by a factor of 2. It is reflected. And, or upside down, whatever you want to write. It was shifted to the right 1 unit and up 3 units. Okay? Yeah. How can I tell it's reflected? I can tell it's reflected because of the negative sign. It makes everything the opposite. And so where y came out to a positive 1 before, now it's coming to a negative 1, and so on. So, yeah, that's how I can tell it's reflected. Are you guys ready to do one yourselves? Heck yeah, let's do it. Okay. All right, so there's yours. If you first want to write down like what A is and H and K, if you want to write that all down first, you can, and show me if you want to make sure you have that right. So we agree A is -3, H is -1, K is -2. Okay. All right. So what it is you look at A to tell you whether it's going to flip over or if it's going to shrink or stretch. This tells you your shift. If you're going to go -1, that means you're going left, and then you're going down. You have to do that first before you graph anything else. So I'm going to be starting at -1, -2, and then the -3 tells me I'm going down 3 over 1 in both directions. And there's your graph. All right, that concludes the lesson.